This video is by John Hoffman and Grace Cooper. We will be doing the 2009 AP Chemistry Free Response Form B, question number 2. A student performs an experiment to investigate the decomposition of sodium thiosulfate in an acidic solution, as represented by the equation above. In each trial, the student mixed a different concentration of sodium thiosulfate with hydrochloric acid at a constant temperature and determined the rate of disappearance of thiosulfate. Data from the 5 trials are given below in the table and plotted on this graph. So this is all the information that is given to you at the beginning of the problem. The first question asks, identify the independent variable in the experiment. If you look back at what you're given, the problem clearly states, in each trial, the student mixed a different concentration of sodium thiosulfate. So, the answer would be, the independent variable is the initial concentration of thiosulfate because it is the variable in the experiment that is purposefully changed. Question B asks, determine the order of the reaction with respect to thiosulfate. Justify your answer by using the information provided. So we're going to be using the table, and we are using trial 2 and trial 1. So when we plug that back in, we have rate 2 over rate 1 equals K2, the concentration of thiosulfate, to the M2, over K1, the concentration of thiosulfate, to the M1. If you plug in your variables, you get 0.03 over 0.02 equals the concentration of 0.075 to the M over the concentration of 0.05 to the M. If you solve further, you get 1.5 equals 1.5 to the M, so M must be 1. Therefore, the reaction is first order with respect to thiosulfate. Question C asks you to determine the value of the rate constant, K, for the reaction. Include your units in your answer. Show how you arrived at your answer. Well, using the fact that M was 1 for the order of thiosulfate, we came up with a rate equation of rate equals K times the concentration of thiosulfate. So, if you divide both sides by the concentration of thiosulfate, you get K equals the rate divided by the concentration of thiosulfate. When you plug in the data from trial 1, you get K equals 0.02 over 0.05. If you notice, the units for this is molarity over seconds divided by molarity. So you are left with K equals 0.04 seconds to the negative 1. Don't forget that you have to have sig figs of 2. Question D states, in another trial, the student mixed 0.1 molarity of sodium thiosulfate with hydrochloric acid. Calculate the amount of time it would take for the concentration of thiosulfate to drop to 0.02 molarity. So we're going to be using the equation ln of your concentration at a time minus ln of your initial concentration gives you negative K times your time. So if you use the ln rules, or log rules, you can get ln over your concentration at a time divided by your initial concentration equals negative KT. Now when you calculate that we're using thiosulfate, you have the ln of thiosulfate at a time, the concentration of thiosulfate, divided by the initial concentration of thiosulfate equals negative KT. If you plug in your values, you get ln of 0.02 over 0.1 equals negative 0.4 times T, which gives you negative 0.161 equals negative 0.4 times T, and T will end up being 4 seconds. Remember that your sig figs is still 2. E. On the graph below, sketch the line that shows the result that would be expected if the student repeated the 5 trials at a temperature lower than that during the first set of trials. At a lower temperature, the rate of reaction will decrease due to the fact that molecules are slower, decreasing the chance to overcome the activation energy. Because rate equals K times the concentration of thiosulfate, and K is a constant, the initial concentration of thiosulfate will also decrease. Therefore, the initial concentration of the line must be smaller, and the slope of the line must be less steep because of a slower rate of disappearance. So we are using what we are given at the beginning of the problem, which is this line, and we have to create another line comparatively to this line. So we know that the initial concentration has to be lower, and it has to be less steep because it's a slower rate of disappearance, giving us the dotted red line that you would draw shown right here. Thank you very much, and I hope this helped.